In this video, we're going to be solving the trigonometric equation using inverse functions. Here we have the secant squared of x minus 2 times the tangent of x equals 4, and we want to write it all into one trig function. Now, because the secant squared of x has the squared, we probably are able to use the Pythagorean identity to convert this. The Pythagorean identity tells us that 1 plus the tangent squared of x equals our secant squared of x. So we're going to be replacing our 1 plus the tangent squared of x with the secant squared of x. So we have 1 plus the tangent squared of x minus 2 times the tangent of x equals 4. So we're going to get everything over to the same side. So we'll subtract 4 from both sides, which will give us, I'm going to write it in order as well, the tangent squared of x minus 2 times the tangent of x minus 3 equals 0. Now from here we can see that it's in a quadratic form. So we can let u equal the tangent of x. So now rewriting this, we see that we have u squared minus 2 times u minus 3 equals 0. And this is something that we can factor. So we want to know what two numbers will multiply to negative 3 but add to negative 2. There's only two numbers that can multiply to 3, and that is 3 and 1. So what symbols do I need to have there to get them to add to a negative 2? If my 3 is negative and my 1 is positive, that will work. And now I can use the zero product property, which will give me that u equals a positive 3, and that u equals a negative 1. So we're going to go ahead and plug our u back in, which is going to give us that the tangent of x equals 3, because remember we're replacing our u, and that the tangent of x equals negative 1. Now in order to separate the x from the tangent, we'll need to multiply by the inverse. So we'll multiply the left side, so the inverse tangent of each, and those will cancel out those tangents, dropping down our x. So we'll have the x equals the inverse tangent of 3, and then doing the same thing here. Crossing those out is going to give us that x equals the inverse tangent of negative 1. To continue from here, we're going to need our unit circles. So let's take a look. Now something that's important to remember during this next part is that the range of the inverse function of tangent happens to be between negative pi over 2 and pi over 2, which is in this area right here, which means nothing on this side is going to be applicable to us. So if we look for where the inverse tangent is 3, there's not a place on the unit circle that gives us that. So to write our answer here, we're going to have the x equals the inverse tangent of 3 plus n pi, because we weren't given a period interval. Now for the tangent inverse of negative 1, that we can find, because in order to get a negative 1, our x and our y values just need to be the same. And that happens in two places. It happens here and it happens there. Now we want the smaller kind of those values, but we want the negative 1. So we want it to be this space here, but we want our value to be between the negative pi over 2 and pi over 2. And technically 7 pi over 4 is outside of that. But we can get there if we choose to go in a negative direction to get there, making this actually negative pi over 4 for this location. So what we can say is here the x equals a negative pi over 4. And then again, because we're dealing with a tangent which only has a period of pi, we have to put plus n pi. And that's going to give us the two solutions to this problem. And we're finished.